In this part of the room, it's about the shadow of objects, since the objects can have different shadows, but it depends on how and where the object is on the plane that this is projected. The ancient Greeks realized the earth is spherical. They observed the shadows that the earth projects on the moon. In this part of the room, you will find the Pascal triangle, which is symmetrical. The right side and the left side are identical. The natural numbers are in order. The sum of the numbers of each line is 2 raised to the number of the line. Even numbers are arranged forming triangles of different sizes. The Fibonacci sequence, which allows us to calculate the area ratio that appears by adding the diagonals if we add the numbers of any line marked in green. The result is the one that appears in red. If the first number of the line is different from 1 is a prime number. So, all the numbers in the line are multiples of it.
The questions are questions and each solution to the question is a response. The solutions of a equation in three variables x, y, z in general form a surface. The images that are next to me are representation of points that satisfy an equation.
The circle is not the only flat figure that can rotate evenly. There are other different figures that also roll because they have constant width. This figure looks a lot like a triangle. It's called Rayleigh's triangle. There are other three-dimensional shapes that have this property. Rayleigh's tetrahedrons have constant width and can rotate evenly in any direction.
Prime numbers. The prime numbers are the numbers that are not result of multiplying two other small numbers. The natural numbers are what we use to count. The first is the one, unit. Prime number two, there are two types, the prime numbers and the compound. It is known that there is an infinity of prime numbers for every 2,300 years. A formula to calculate time is not just know. To know is a numbers prime. Many derivations must be made, and this very late even with a supercomputer. This is why the prime numbers are used to encrypt communication on the internet. The largest prime numbers discovered so far are only 5, and each one has millions of digits, and they are all grouped in one term. We can see them in this display case located at the top. In display, you can find the volumes of the largest first numbers discovered so far, and this space is reserved for the next prime numbers, which will be incredibly large. There is a way to discover if a number is prime or not based on cubes. If that we must choose a number and take that number of cubes, then we must trim the former rectangle with him, and if you cannot, then the number we choose is prime. In this case, I choose the number 8, but I could not form rectangle, so the number 8 is a prime number.
Pythagoras theorem. This theorem says that all triangles that have a right angle does not matter the position. If we had the squares of their legs that are tan form right angle, we will obtain the square of their hypotenuse. An example is that if we turn this device, the liquid that inside the figures A and B completely fill the figure C.
This line segment is formed by an infinity of points. It is very thin because it has length, but it does not have width. Infinity is greater than numbers. At the end of the 19th century, Cantor imaged his collection on the wall to see that the points that form any line segment cannot be counted. Even if we use all the natural numbers, it is true that the sum of natural numbers is infinity, but there are more points in any line segment, and that was Cantor's show. Since it bears his name, the Cantor ensemble. The set is one of the most surprising modern mathematical constructions. This can be demonstrated through the screens. We reproduce the image form of the infinity, as we will do with the Universum battery. And he says that the smaller the image is in, the more together the points are.
Brachistochrona, shorter time interval. In 1696, the Swiss mathematician Johann Bernoulli proposed the following. I, Johann Bernoulli, I am writing to you the most brilliant mathematician in the world. Having two points, A and B, in vertical plane, with each the curve that must follow a particle on which only gravity acts, to form from A and hit to B in the shortest possible time. He received 5 correct answers. Jacob Bernoulli, Gottfried Leibniz, Guillaume Hospital, Ehrenfried von Schirnhaus, Isaac Newton. Jacob Bernoulli, his brother Bernoulli's number. Gottfried Leibniz, mathematician pioneer in differential and integral calculus. Guillaume de Hospital, author of the first book of calculation. Ehrenfried von Schirnhaus, German scientist, philosopher, and mathematician. Isaac Newton, the best and most accepted so far, not always the shortest right in the first. An example could be the following.
You can decorate the plane by covering it with mosaics. When all the mosaics come together perfectly, without overlapping and without leaving gaps, we have a tiling. Each of the mosaics is a polygon and is called a tile. If all the tiles are equal, the only regular polygons with which the plane can be tiled are the equilateral triangle, the square, and the regular hexagon.
Let's talk about anamorphosis. The anamorphosis means transformation. In this case, it is a transformation of the space according to the reflection of a cylindrical mirror. The distorted image of Marilyn Monroe that is seen at the top looks perfectly thin through the mirror. The mirrors are very useful to perceive some abstract mathematical transformation. Cylinders, spheres, plane give us an idea about how different transformations of space act and interact.
The so-called number pi is the mathematical relation existing in geometry, the result of dividing the circumference of a circle well-known in diameter, and after its apparent simplicity the height and measuring properties. There were many people who tried to calculate more figures of found out in 1961 an IBM computer surpassed the 100,000 figures after 9 hours of work.
There are four ways to place chords that correspond to the symmetries of a rectangle. The symmetries of a rectangle are generated by two reflections: reflection in the horizontal, vertical reflection. The rotation of 180 degrees around the center of the rectangle is obtained by applying the two reflections consecutively.
The ruled surfaces are those that can be generated by the movement of a line called gyratories that follows a certain path. These surfaces contain two types of family of gyratories that obtain the name of doubly regulated surfaces, which are the hyperbolic paraboloid and the hyperboloid of a leaf.
Quirrell Mexican hypercube, a polytope that does not have reflection symmetries. This polytope is formed by 16 vertices, 32 edges, 12 faces, and 4 three-dimensional cells. It is a hypercube because it has the same vertices and the same edges as the hypercube, but each of the faces is an octagon, and although they are of dimension, two cannot be flattened. Mathematical objects cabinet. Let's 1. Clover knot, trivial knot, Borromeo knot. Let's 2. Double helix. Let's 3. Klein bottle, ball, Klein bottle. Let's 4. 8, 9, and 10 hyperbolic surfaces.
The topos, the square, the cube, and the hypercube. They are the family of figures that includes polygons, polyhedral, and all their peers. Some examples are: the square is a polygon that is formed by 4 vertices and 4 edges. The cube is a polyhedron that is formed by 6 faces, 8 edges, and 8 vertices. The hypercube is a polytope of dimension 4 that is formed by all 8 three-dimensional cells, 24 faces, 32 edges, and 16 vertices. Have symmetries of rotation and reflection. Rotation: if 3 is a way to rotate, it stays the same. Reflection: if there is a way to reflect, it and that it remains the same.
After a history of 2 millennia, we know that in the plane there are only 3 possible geometries, according to the fifth postulate of Euclid. The Euclidean is the geometry of the plane with which we work almost always. The hyperbolic is the geometry of the saddle. The elliptical is the geometry of a sphere in which there are no parallels. We are surrounded by conics. The reflective properties of the conics are so characteristic and unique that if we have any curve that has any of these properties, it is necessarily a conic arch. It's like saying that if walk like a dog, quack like a dog, then it's a dog.
Civil mathematics. This is Amman-Vinker tessellation from the year 2017 by Darío Alatorre Guzmán. The digits of pi. The number pi is equal to 3.1416. It is an irrational number, so its decimal expression is infinity and does not repeat itself. One way to represent the digits of pi is with colors. Each of the rectangles
has a color and that color is determined by 6 digits of pi. 2 digits for the amount of red, 2 for green, and 2 for blue that combined give a particular color. Complex variable function of the year 2016 by Adolfo Guillot with satellite images from NASA. The one on the right, the complex cosine, the one from the left, zeta to the fourth power plus zeta to the cube plus zeta to square plus zeta plus 1. In these two images we can see the cosine function and the one determined by the zeta polynomial to the fourth power plus zeta to the cube plus zeta to the square plus zeta plus 1.
The Lorentz Attractor 2017. In 1963, Edward Norton Lawrence, a mathematician who decided to dedicate himself to meteorology, simplified the equations that model the phenomenon of convection in the atmosphere, and found to his surprise that even it is to model a differential equation with only the Mad Rosette 2016 imaginary collection, repeating a simple rule a huge number of times may seem very useful, for example, to add a number to the square. If the number is large, its square will be larger and the square of its square will be even larger. We can say that in each iteration the result is getting closer and closer to infinite. The Malvern Set 2016 Imaginary Collection. If the rule is a little more complicated, choose a number C, square C, and take the sum of both square C plus C. According to this rule, which numbers go to infinite and which do not? This question has a very interesting answer. If instead of considering only the real numbers we extend it to the complex numbers in particular because the complex numbers form a plane, and in a plane we can make drawings.